All right, so let's see. That is now recording. Okay, well, hope everybody's doing okay today. We're going to go ahead and get a little further with our lesson. Then tomorrow we should be able to actually get quite a ways into it. But we started talking about the unit circle yesterday, and here it is right here. Why do we call it the unit circle? Well, it is a circle, but what's its radius? Just one unit. That's exactly right. Okay, from the center to any point on the circle, the radius is just one. So we refer to it as the unit circle. Okay, so what we're going to do is we're going to take this circle and we're going to go ahead and put it right on top of your Cartesian coordinate system. You know, your x and your y axes where you would go ahead and plot points. So this would be your x-axis, this is your y. So the very center of the circle is also the origin, where the axes are going to intersect each other. So I thought it'd be a good idea to go ahead and review. I've already got the degrees up here, okay, which most people seem to be doing just fine with. You'll notice the axes themselves are in multiples of 90. Okay, now the cluster of 3 points in each of the 4 quadrants, those points themselves are 15 degrees from each other, but from the closest axes, they're 30 degrees. So see, 60 plus the 30 will give me 90. Okay, 180 plus the 30 will give me 210, and all the way around. And I believe yesterday we did get the radian measures, but let's go ahead and review that again. Let's see here. We were looking at multiples of 45 and then multiples of 30. Yes, thank you. Did anybody else need the key? Okay. So if we were looking at a multiple of 45, what were we going to be counting by? By fourths, yes. So multiples of 45, we've got 45, of course, 90, 135, 180, 225, 270, 315, and then all the way back around to 360. So I would go ahead and say first 1/4 pi, okay, or pi over 4. You can actually write 1/4 pi if you want to. And then at the next multiple, this would be 2/4 pi. And then 3/4 pi, 4/4, and you would just continue until you finish. So what does 2/4 reduce to, though? Yeah, so this would be pi over 2. And see, we're already accustomed to knowing that's pi over 2. Then right here, this would be 3 pi over 4. Then we would have 4 pi over 4, which is pi. 225 would be 5 pi over 4. 6 pi over 4. But 6/4 would reduce to 3/2. Okay, again, we're accustomed to seeing 3/2 there. So 3 pi over 2. What number are we on now? 7. Okay, so 7 pi over 4. And we finally get all the way around to 8 pi over 4, but 8 divided by 4, that's 2 pi. So just count by fourths for multiples of 45. Okay, and you're going to notice when you start doing the same thing for 30, the multiples of 30, when you count by 1/6, some of those multiples of 45 are also multiples of 30, but you should still, again, get the same answer. So for 30 degrees, that's just 1/6 pi. And then just like the fourths, 2/6, 3/6, 4/6, all the way around. So let's see here. What is 2/6 going to become? Yeah, so that's pi over 3, right? Because that's just 1/3. And then we have 3/6. So 3/6 becomes the 1/2, so we already have that one. What am I going to have here at 120? 2 pi over 3, because it's 4/6, right? So 1/6, 2/6, 3/6, 4/6. But the 4/6 reduces to 2/3. Then 150 will have 5 pi over 6. And then just like before, where we had 4 pi over 4, we now have 6 pi over 6. Well, again, that's just pi. What would 210 be? Yeah, this is 7 pi over 6. 240. Now it's 8 pi over 6. So what is 8/6? 4 over 3. Okay, then 9 pi over 6, but the 9/6 becomes 3/2. Now we're up to 10. So what is 10/6? Okay, that'd be 5 over 3. So 5 pi over 3, 330. We're up to 11. 11 pi over 6, that one will not reduce. And then we finally get around to 12 pi over 6, but 12 over 6 gives me the 2 pi. Okay. And if you check any one of these, if you go ahead and take any of those degree measures, multiply it by pi over 180, you're going to get that corresponding radian measure that we just came up with. Okay. So now it is 2/3 of the way done. Okay. So any questions on that? I think this is where we got to yesterday, right? Okay. Now, the only thing left, I want to know the coordinate of each of those 16 points, the actual x comma y location. Now, 4 of them are going to be very, very simple to figure out. There won't be any work involved. Again, why do we call it the unit circle? Because it's a radius of 1, right? So if I start here at the origin and I move right to this point, okay, what would that point be? It would just be 1 comma 0, right? Yeah. Because see, once I got here, I didn't move vertically. Okay, so what if I wanted to go to this point on the circle where we have 90? That'd be 0, 1. Yeah. See, we're just moving out along the axes. Okay. What about the point at pi? Okay, that would be -1, 0. And we've got one left right here at 273 pi over 2. 0, -1. That's it. Okay. So we've already got 4 of the 16. Is everybody okay with that? Now, the other 12, there's different ways that you can go ahead and do this. For each of these 12 points, 3 in each of the 4 quadrants, you can connect that point perpendicular to the x-axis. Like, let's say we wanted this one right here. I would connect it straight down, and see, I can create a right triangle, correct? Well, let me go ahead and show you something pretty cool. If I did that for all of them, we're looking for 12 points, so there'd be a total of 12 triangles, okay? But here's what's really nice about this. It's just the same 2 triangles repeating over and over again, okay? Because it's the unit circle, okay, what's across from 30 is going to be 1/2. What's across from 60 is going to be square root of 3 over 2. And then the radius will be the hypotenuse of the triangle. Well, that's just 1. Remember, because it's the unit circle. Now, if anybody's, curious why these values are showing up, remember the relationship that the sides have for a 30, 60, 90. Across from 30, we always call that x, right? Across from 60, we say that's x square root of 3, and then the hypotenuse is always double x. Okay? So you can kind of start to see where these values come from. If the length of the hypotenuse is 1, but it should also be 2x, and we'll just divide through. See, that's where I get the 1/2 from. Okay? That's where I get the 1/2 from. And then if I took 1/2 the x times square root of 3, well, there's your square root of 3 over 2. Okay? Same thing is going to apply over here. If it's one of the 45, 45, 90 triangles, the radius, the hypotenuse, is always going to be 1. So the 2 lengths will always be square root of 2 over 2. Okay? Does anybody want me to work backwards on that one and show you how we would get that? You do? Okay. So let's do it. For this type of triangle, this is the only isosceles right triangle we have. So the legs are always x, and the hypotenuse is always x square root of 2. Okay. Well, the only side length I know for sure right now is the 1 because it's the unit circle, right? So I'm going to do just like I did over here when I set 1 equal to 2x. I'm going to set 1 equal to x square root of 2. Well, how would I solve for x? I'm sorry? Well, let's see. What's the opposite of multiplication? Divide, right? So I'd go ahead and divide through by the square root of 2. Because all I want to do is get that x by himself, right? So I've got 1 over the square root of 2 is equal to x. But what happens, what do we like to do when we see a radical down below? Yeah, we like to rationalize it. So square root of 2, square root of 2. Well, let's see. 1 times the square root of 2 is the square root of 2. But what's the square root of 2 times the square root of 2? 2. So see, that's exactly where those side lengths come from. Okay? And if you're familiar with these 2 right triangles, Okay, you can find any point that you want on the unit circle. All right, so let's go back over here. Because I started in standard position and see I rotated to 30 degrees, this one would be 30, this one would be 60. So from the triangle we were just looking at, what's always across from 30? What was it? It's 1/2, right? Okay. So I know that this length is 1/2. What was across from 60? What was across from the 60 angle? Square root of 3 over 2. And then your radius, your hypotenuse, is just 1. So remember, we're just taking this circle and we're putting it right on top of that xy plane. So imagine I want to go from the origin here to this point right here. Well, all I want to do is move horizontally, square root of 3 over 2, and then I'd move vertically 1/2. Okay. So that this guy right here, his coordinate would be the square root of 3 over 2, 1/2. It's coming from that same triangle. Okay. Let me go ahead and show you one more, and then I'll give you the shortcut for these. Okay. All right, so let's say I want the point here at 45. I want to know what the coordinate on that circle is. So I'm going to drop another segment straight down, perpendicular, forms my right triangle, if I could draw a straight line here. There we go. All right. So we rotated 45 degrees, so this is a 45 triangle. Remember, the radius is 1. Now, going back over here, what were the side lengths for this triangle? They were both square root of 2 over 2, right? So I know this is square root of 2 over 2, square root of 2 over 2. So I'm just plotting a point. I want to go from the origin here to this point right here. So I'm going to move horizontally and then vertically, just like you plot a point. So what would the coordinate be? Square root of 2 over 2, square root of 2 over 2. Okay. And it's the same two triangles over and over again. Okay. Let's do this last one. From 60, I'm going to drop a triangle straight down like that. This time we rotated 60, right? So this is 60. This is 30. Well, what is across from 30? The 1/2. So this side has to be 1/2. What's across from the 60? The square root of 3 over 2 with a hypotenuse of 1. So how would I go from the origin to that point right there? Yeah, it would just be 1/2 square root of 3 over 2. Now, that's all there is to it. Okay. Now, you can go ahead and do that for each of the other 9 points. Go ahead and create the same triangles, get those side lengths, okay? It's perfectly fine, but I would say at this point, if you already have the first quadrant, if you have those first 3, well, then just use symmetry. All I want to do now is just take these 3 points, and I want to reflect them across the y-axis, okay? So if I were to have a point over here and I reflected it across the x-axis, or excuse me, the y-axis, what's the one thing that's going to change in that point? There you go. The x value is going to become negative. So imagine I could fold this circle right down the middle. Well, wouldn't this point here at 60 correspond to this 120? Yeah. And since I know that coordinate there is 1/2 square root of 3 over 2, I know this one would be negative 1/2 square root of 3 over 2. All I'm doing is reflecting it over. I don't even have to worry about the triangles anymore. Okay. What would this point here, square root of 2 over 2, square root of 2 over 2 look like when I put it over to the 135? Yeah. The only thing that's happening here, the x is negative. Man, this is not allowing me to write today. There we go. And what point would I have at 5 pi over 6? Or 150 degrees? There you go. This point over here, this would be negative square root of 3 over 2, 1/2. Okay. And just keep those points reflecting. Now let's take those 3 points that you just told me. Let's go ahead and reflect them down across the x-axis. So this right here, the one we just got at 150, that would correspond to 210, right? Those would match up if I folded along the x-axis. Well, what's going to change here? Yeah, see here in the third quadrant, they're both negative. So for 7 pi over 6, this would be negative square root of 3 over 2, negative 1/2. Okay. The 225, that would correspond to the 135, right? So what would the point at 225 be? 5 pi over 4. Negative square root of 2 over 2, negative square root of 2 over 2. And our last one here, the 240, would correspond to the 120, right? Negative 1/2, negative square root of 3 over 2. Perfect. Okay. And now for this last one, you basically can do what you want. You can take the third quadrant and you can reflect it across the y-axis right here. Or I can take the points that I originally started with and I can reflect them down over the x-axis, whatever you prefer. But take about 30 seconds, okay? Write down what you think the coordinates at 300, 315, and 330 degrees are going to be. Or if you want to use one of the triangles, please feel free. Okay. Okay, again, look for patterns. When I reflected the first quadrant to the second, x became negative. When I reflected that to the third quadrant, they're both negative. So what should be happening in the fourth quadrant? Are they both negative? Just one of them? Just one. Which one? The y. So what's this one right here at 300 degrees? 1/2, comma, negative square root of 3 over 2. Perfect. What's the coordinate at 7 pi over 4? There you go. And our last one, 11 pi over 6. That's it. That is our completed unit circle. Okay. Now, once we started reflecting, it went a lot faster, right? Okay. You ready to see something really cool? I mean, more cool than what we normally do in here? Lily Bell, yeah. Yes, yeah. Okay, so I'm going to go ahead and erase this very quickly. I want to go ahead and show you something. Okay. This is a very, very quick way of filling in the unit circle, because if you have the first quadrant, you just start reflecting it, right? Now remember, we start at 0 degrees. This goes to 90. The first one is 30, 45, 60. If it was a multiple of 45, we count by fourths. So this would be pi over 4, 2 pi over 4, so that's pi over 2. If it's a multiple of 30, we count by sixth. So this is 1/6 pi, 2/6 pi. All right. Now, let me go ahead and show you another full unit circle. Take a look at all of these points, not the quadrantals, not the axes, just the ones in the middle of the quadrant. What is every one of those values doing? They're all doing the same thing. Doesn't matter if they're positive, if they're negative. What's the one thing they all have in common? Okay. They're all being divided by what? By 2, right? Every single one of those is being divided by 2. So let's do this. Divide by 2, 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 divide by 2. Now, if you go ahead and start at the very top on the inside, and you just start counting. 1, 2, 3, and then count back up. 1, 2, 3. And then take the square root of the numerators. So what's the square root of 1? 1, so it doesn't look like it changes. See, in seconds, you've got all 3 of those points. I can then take this and just reflect it over. I could have the unit circle in no time at all. How's that?
Why don't you show us that in the first place?
Well, normally I go ahead and wait to show that because then the people are like, oh my God, that's a lot of triangles. So you can appreciate that better and you're more willing to do that. You're like, while I know it can be done this other way, I know there's a faster way here. Okay. All right, so that bell should be ringing actually in just a few seconds. Nice.